All right, welcome to this video on graphing the square root function. In this video, we're going to cover the general shape of the graph, the domain of square root functions in general, and we're going to talk about a pattern which will allow you to graph the function without, making a standard table of values. If you look at the function I have over here, y equals the square root of x, so you can see that's the parent square root function. And all the varieties of this type of a graph will come from this function. This is the original function. And as you can see over here, the graph has this kind of like this swooping pattern. It's going to have, as you can see over here, it's going to wind up having a starting point, but it will not have an end point. All right, this graph is, for this particular graph, the parent graph, it's going to start at 0, 0, and it's going to wind up going off into positive infinity. As x gets larger and larger, the graph is going to go off to positive infinity. And this is the general shape for all square root functions. Some of the graphs will be a little bit taller. Some of the graphs will be a little flatter. Some of the graphs will be reflected over the x-axis. And some of the graphs may even go to the left. As you can see, this one's going to the right. Some of the graphs may be reflected over the y-axis. But, nonetheless, they're still going to have this general swooping pattern. So what I want to do now is I want to talk about domain. That's going to be the next topic that we have here. And the domain of any function is the allowed x values into the function. So, what x values can we allow into this function or any function so that the function doesn't become undefined or have a non-real result. And since we're graphing the function on a real coordinate plane here, a real coordinate system, all of my inputs, my x values, have to be real, and so don't all my y values. They all have to come out real with real numbers. So if you remember that, when we're taking a square root of, just in general terms, when we're taking a square root, we can't take the square root of negative numbers because we're going to wind up with an imaginary result. Like if we take the square root of -1, we're going to wind up with the imaginary number I. So what we need to do is we need to make sure that everything under the radical, and this piece here, the term under the radical, is actually called the radicand. We need to make sure that the radicand, after we substitute values in for x, the radicand stays positive, all right, or non-negative. The radicand must be non-negative, which means we can have 0 under there, and we can have positive numbers, but we just can't have anything negative. So the domain is, we have to make sure that the radicand remains non-negative. All right? And the easy way to do that, I'm just going to scroll this down a little bit over here. I'm going to come under the graph. The easy way to do that is, all we're going to do is we're going to take if I rewrite the function here, we have y equals the square root of x. That was the original parent graph. And all you need to do to figure out the domain for any radical function is just take what's under the radical, so the radicand, this time it's x. And since the radicand has to stay greater than 0 or equal to 0, we're just going to take what's under there and we're going to set it greater than or equal to 0. So that's going to be our domain. That's how you find the domain of any radical function. You just take what's under the radical, the radicand, and set it greater than or equal to 0. And this also tells us, so you can see this is my inequality is pointing to the right. It's saying take numbers greater than or equal to 0. This is also telling us the direction that the graph will point. As you can see up above here, this graph is pointing to the right, and my inequality is also pointing to the right. Now, if we had another function, if we had y equals the square root of -x, and we wanted to find the domain of that function, again, we would take what's under the radical out, and we would make it greater than or equal to 0, and we would solve for x. And we would have to divide by -1, And remember, when we divide by a negative, the inequality symbol is going to wind up changing directions. So this means that x has to be less than or equal to 0. So in the example above here, we have a positive value in front of x. This is going to come back later when we do the graphs. So you see my coefficient here, if I just move this out of the way, the coefficient of x is positive 1, and the graph is actually pointing to the right. And in the example below it, my coefficient of x was negative 1, and you can see the inequality here is actually pointing to the left, and that's how the graph would wind up. This graph, when we do something like this, we'll wind up doing this on the last example. This graph is actually going to go to the left. So it's kind of an easy way to figure out whether your graph is going to go left or right. I'm going to use this coming up later on when we do the graphs themselves. So all you have to do is look at the coefficient of x. If it's positive, its graph's going to go to the right. And if the coefficient of x is negative, the graph is going to go to the left. That's kind of an easy way to remember it. So, like all graphs, an easy way to plot them is just to make a little table of values. And we're not going to do this all the time in this video. We're just going to do this for now, just for the visual. So I'm going to erase the highlight here. And to make the graph you see here, all we did was substituted some numbers in. And remember, my graph cannot be to the left of the y-axis because we can't have any negative numbers under the radical. So all we did, and since we're taking a square root, if we don't have access to a calculator, it's easy to graph it if when we put numbers in for x, we just pick numbers that are squares. So the first number we started with was 0, and we took the square root of 0, so that's 0. So we have this point on the graph, 0, 0. And then the next square after 0 was 1, and the square root of 1 is 1. So we have this point on the graph. And then we did 4, and the square root was 2. And then we had 9, and the square root was 3. That's how this graph was created. We have that general shape. All right? The start value, if I write it over here, and remember, this parent graph is kind of like the model for all the other radical function graphs. So we're going to use this as a model to create all the variations that can come with this type of a function. So the start value we talked about was at 0, 0. And you can see here, as x is going to positive infinity, right? So as for this graph here, as x is going to positive infinity, the graph itself is actually, it's going out and it's actually going upwards. The y coordinates are also going to positive infinity. If we were to reflect this graph over the x-axis and just mirror it, we would have this diagram here. So we would have 1, -1, and then we would have 4, -2, and then we would have 9, -3, and then the graph would look like this. X would still be going to positive infinity, so we would have x would go to positive infinity, and in this case, this graph is actually going out and down, so the y values would be going to negative infinity. All right, and what creates this reflection here, we're going to talk about this in a minute. If I come back over here to the original function, you see the coefficient in front of the square root is positive, and whenever that coefficient is positive, you're going to get the graph going upwards. All right, I'm going to come back to this in a second. The graph is going to wind up going upwards, and if we had something that looked like this, y equals negative square root of x, now the negative is on the outside, the graph would go downwards. All right, the next thing I want to talk about is the general form of the graph. So, because we're going to use this information to create the rest of the graphs. The general form, now I know we have just this here. We have y equals square root of x. But the whole full formal way to write this function would be this. Y equals a times the square root of x minus h plus k. All right, and we've already talked about start value. So we've already, gone over what the start value is. And these graphs are always going to have a starting point, start value, but they're not going to have an ending point. They're going to go off to positive or negative infinity. So the h, you see here under my radical, the h and the k will actually be, h comma k, will actually be your start value of your function. Again, we'll use this in a little bit. So whatever the values are under the radical here, in this k value, we're going to put them in this parentheses and figure out what the coordinates of the start value are. Just like this 0, 0 is up here. And then the a term, so you have this value here, this a, the coefficient in front of the square root. That a term, that just tells us how fast the graph will rise or fall. So I said in the beginning, sometimes these graphs are taller than others or flatter than others. And you can also see that it's reflected over the x-axis. Well, that's basically what this term does right here. That's what A is going to do. A is going to tell us if the graph is going to get really steep or really flat. And it's also going to tell us if the graph is going to be reflected like this graph is right here. And we're going to get into that in a little bit. All right. And the next thing I want to do is I want to talk about a pattern, a step pattern, and that's how we're going to actually graph this. So here's how the pattern works. Now, this general pattern will only work. So if I take, let me write the original function here. So we have y equals the square root of x. This general pattern, all right, I'm just making this little note. This general pattern is useful when the coefficient of x is 1. All right? If the coefficient of x is not 1 or negative 1, negative 1, we'll get into this in a little bit, but the negative 1, again, is just going to tell us the graph is going to go to the left. If your coefficient is anything but a 1 or a negative 1, this pattern isn't going to work. So I just wanted to get that out right now. So let's figure out what the pattern is. If I look at the graph, so we have our graph, and all the radical function graphs will follow this pattern, again, as long as the coefficient is 1 or negative 1. So if we start at the start value, all right, I'm going to change the color here. We're always going to walk up 1 unit because the graph is going up. If the graph was going down, we'd walk down, obviously. So the pattern is we're going to go up 1 over 1. All right, so I'm going to make a little table here. So here's our table. This graph is going to go up. And when I say over, this graph is going to go to the right. Right? So the first step is going to be up 1, right 1. And then from that point here, again, we're going to walk up 1 unit. So we're going to do 1 unit. And then the next step over is going to be 3. So we're going to go 3 units to the right. And then we're going to do it one more time. So we're going to walk up 1 unit, and we're going to walk over the next point on the graph that we actually get a whole number value is going to be over 5 spaces. So you can see we were at 0, 0. Then we went up 1 and we went to 1. Then we went up 1 and went over to 4. So that's 3 spaces over. Then we were at 4, and then we went over to 9. So that's 5 spaces. So this is your general step pattern. All right? This is what we're going to use to graph all of the functions in this video. Now, this pattern will always be the same as long as one thing. I've already told you about the coefficient of x. If x is not 1 or negative 1, this pattern isn't going to work. The only thing that's going to change for this pattern will be this column here. All right? So let me backtrack 1 second. This column could be either up or down, all right? or in this column could either be right or left. This pattern will always be the same. Whether we go right or left, it will always be 1, 3, 5. All right? The only thing that could change is this. This may not always be a 1, and that's determined by the a term of the function. So for instance, if we had y equals 2 square root of x, my a term, the a term is always outside the function. A is 2. So what we would do, we would start out with the original table, and we're going to do this when I do the graphs. We'd start out with the original table, and then all you would do is you would take this value of 2, or whatever value is in front of the square root, and you would just multiply it times that step there. So instead of going up 1, up 1, right 3, and then up 1, right 5, our new table, if I move this up, would now be 2, 2, 2, 1, 3, 5. Okay? And again, I'm going to do this in detail when we do the graphs for real. So that's our full pattern. Hopefully that made sense. I had said a little while ago that the general form of these graphs was y equals a times the square root of x minus h plus k. If we use this general form to the parent graph, y equals square root of x, just to show you how these pieces would go. Remember, a is always out front, so the coefficient here is 1. So my a would be 1. And then I don't see, h is always going to be under the radical. So if I don't see anything under the radical, my h is going to be 0, all right? If there's nothing under the radical besides an x, my h will be 0. And k is always on the outside of the radical, so it's going to be out here. And again, I don't see anything on the outside of the radical here, so that means it's also going to be a 0. So this is actually plus 0, and this would be minus 0 inside the radical. So my h would be right here. It would be actually 0 because I don't have any value. And my k, since we didn't have anything, would also be 0. So this would be 0, 0. And when we do the graphs coming up, I'm going to cover, again, this full general form when I take all the pieces out, the a, the h, and the k. There's only one trick to this, and that's with the h term. And I'm going to get into this when we do the second example on the next section. When we take this h term out, whatever sign is under the radical, we're going to wind up changing it when we take it out, like what I did over here. And I'm going to explain that in detail right in the next section when I go over the different types of graphs. So I'll see you in a minute, and we'll start doing some graphs. Okay, welcome back. So now we're going to graph this function here, y equals 2 times the square root of x. And I kind of already alluded to that in the last section. And you can already see it on the graph. I'm going to show you how we came out to this. So the first thing I like to do is I'm going to just call out the general shape or the general form here. Remember, this function is actually, if we took it out and we wrote it officially here, this is really y equals a times the square root of x minus h plus k, as I said a little while ago. All right? And my a term is always going to be in front of the function, so that's going to be a 2. So we're going to say a is 2. And again, the h is going to be under the radical here, and I don't have any h term. There's no value except x. And I just got through saying in the last section that if I don't see any value, h is going to be 0. And then we have the k term, and again, I don't have anything outside of my radical function here. So there's really nothing there. So this is really plus 0. So if we wanted to write this officially and formally, this would be y equals 2 times the square root of x minus 0 plus 0. That's, if we wanted to use this this type of a notation. So that means that h is 0 and k is also 0. All right. So here are the steps on how we like to do this. So number one, I like to figure out the direction of the graph. I want to know is the graph going to wind up going up or down or left or right. So for looking at whether the graph is going up or down, right? So if it's going to go up or down, you're going to look at the A term. And what we said was if A was positive, the graph is going to wind up going up. If A is negative, the graph is going to go down. So this graph is going to go upward. And I also want to know, is the graph going to go right or left? And that is going to be determined by the coefficient in front of x. And I said in the other section, if the coefficient of x is positive, this graph is going to go to the right. And if it was negative, it would go left. So this one is actually going to go right. So this is kind of what I do in step number one, is the graph, which way is it going? You can kind of see how this one worked out, right? This one's going up and to the right. Next thing I do is look at a start value. And the start value is always going to be h comma k. So my h and my k, I listed it up here, was 0, 0. So it's 0, 0. So after you figure out your direction, you put your start value on the graph, 0, 0. And then you're going to use your pattern. And again, you don't have to do this table. I'm just kind of doing this for the visual now. We know the graph is going to go up and right. And the general pattern was, this column was all ones. And then the pattern for, movement right or left was 1, 3, and 5. And then all you have to figure out now is this column going to change? Is the up or down column going to change? And the only thing that's going to change it is this A term over here, this A term of 2. So we're going to take the 2, so A equals 2, and we're just going to multiply that times this column. So what that's going to do, it's going to change that up column. So now our new table is going to be, if I just rewrite it quickly, we're going to have 2's and everything, everywhere in this column, and this right column will not change. So then we just sketch the graph. So we start at the start value, 0, 0, and then from there we're going to go up 2 spaces, over 1. You can see it's already there on the graph. And then the next thing we're going to do is we're going to go from this point, we're going to go up 2, and then right 3. You can see that on the graph. And then one more time, we're going to go up 2 and right 5. And then you see we have the sketch. And that's it. That's the whole pattern. All right. So just as a note, if A is positive, the graph is going to go upwards. And if A is negative, the graph is going to wind up going downwards. We're going to do one where the graph is reflected in a little bit. The next one I want to do is this graph here, y equals the square root of x minus 1. All right, so this one, if we were to write the formal version of this, this would be y equals the square root of x minus 1. Remember, this is plus 0. I don't see anything outside my radical. So writing the pieces out, the A term would be 1. It's right here. It's in front of my radical. H. Now here's the deal with H. All right, so H, you can see here, H is right here. But when we take H out, you actually have to change the sign of H. So H is always going to change signs on you. If the number under the radical is a negative, H is actually going to be a positive one. I'll explain that in a minute. And then K is going to be 0. All right? So now, why is the H term going to switch sign? To find your domain, you take the radicand and we set it greater than or equal to 0. If we solve this equation, x has to be greater than or equal to 1. So this is telling me, this is my domain, this is telling me where my graph has to start. So it actually it changed from a negative under the radical to a positive here. When we took it outside and solved for x, it changed from a negative to a positive. So that's why the h term will switch. So the same thing would happen if I had this. If I had y equals the square root of x plus 1, and we wanted to figure out what h is, again, if I took, the radicand outside here, we would have x plus 1 greater than or equal to 0 if we were finding the domain, and you would subtract 1, so we would have x is greater than or equal to negative 1. So it switched from a positive to a negative. So that's the only tricky thing with h. H is going to switch signs on us. So you just have to remember that. If it's positive under the radical, it's actually going to come out as a negative. That would be, your h would be negative. And if it's negative under the radical, as I have here, when it comes out, it's going to come out as a positive. All right, that's the only thing. We would figure out our direction here. So my direction for this graph, the direction for the graph would be, we're looking at the coefficient of A, and it's positive, so the graph is going to go up. And then we're looking at the coefficient of X, and the graph is going to go right. So that's good, we know that. And then we're looking for the start value. And the start value is always going to be h and k. And then we have our h and k value. So h is 1 and k is 0. So my start value was 1, 0, as you can see right here on the graph. And then we just figure out the pattern. We figure out our steps. Well, the graph is going to go up and right. And then we know the general pattern of the graph. So these are going to be 1s, and this is going to be 1, 3, and 5. And the only thing we have to worry about is the a term. So a is 1. And if a is 1, we don't even have to do anything to this column. So this is going to be the pattern that we're going to use. All right, so we don't have to multiply anything. So we're going to go from the start value, we're going to go up 1 over 1. So we have this point right here. So the next one we're going to do up 1 over 3. So we're going to go from here to up 1 over 3, 1, 2, 3. We would have this point right here. And the next one we would go up 1 and then right 5. 1, 2, 3, 4, 5. So we'd be right there. Right? And then you can see the curve sketch there. And that's really it. These are the 3 steps that we're going to do going forward. We're going to figure out the direction, the start value using h and k, you can see it there, and then we're just going to figure out the steps. And the steps, the only thing that's going to change, again, is going to be this column right here. It's either going to go up or down, and we'll have to multiply it times the a term, and then, we're going to do one at the end where this graph is actually going to go to the left. So hopefully that's all, sitting well and making sense. And I will be right back if I clean this up a little bit. We're going to be right back with a few more graphs and the different variations of the radical functions. So we'll be back in a little bit. The very first function I'm going to have us graph is y equals 2 times the square root of x minus 1. And the way I like to do these is I like to write out my pieces. Now we know the terms, the a term, the h term, and the k term. I like to write out my pieces right away. So right here, we're going to have a is 2. H, remember, h is the tricky one. Remember, when you take h out, and h is always going to be under your radical here. If there is an h term other than 0, you'll see it under your radical, and when we take the h out, we have to switch the sign. So you see it's minus there. It's actually going to come out as a positive. And then I don't see a k term on the outside here, so it's actually plus 0. So that means that k is 0. So once I have those pieces, then I kind of go through my steps. And the steps are going to be the same for all the functions. So the first thing is I like to determine the direction. I like to figure out, is the graph going to go up, down, left, or right? And what you're looking at is basically you're looking at the A term and you're looking at the coefficient of x. So if I see A, and we've got it here, A is positive, I know that the graph is going to wind up going up. And if I look at the coefficient of x, I also see that's positive. And as we mentioned before, the graph is going to go up and to the right. All right. The next thing I like to do is my start value. So I like to list out my start value and get that on the graph. And remember, the start value is h comma k. So this start value would be the point 1 comma 0. We would have these up here. That's going to be my h and my k. So I'm going to put that on the graph. So we're going to have 1 comma 0 right here. And then all we need to do now is figure out the steps. And the basic steps, again, we know the graph is going to go up and to the right. So that's going to be my little table here. And as you get used to this, you really don't need to make this table. I'm just going to do it for visual purposes. So we know that as long as the coefficient of x is either 1 or actually -1, the steps to the right or to the left, incidentally, once I'll show you one at the end of this where it's actually going to go left, are always going to be the same. So it's going to be 1, 3, and 5. And we said that this column here, either the up column, or this would either be up or down in this column right here, is always going to be 1s here. And then all we're going to do is take a look at the A term. Remember, A is going to affect this column. So we always need to look at A to determine whether, the steps are going to go up a little faster. And we said A is 2. So all we're going to do is take the 2 and multiply it times everything in this column, which is just going to change it. So that just means the graph is going to rise up a little faster. So all these values in this column here are going to become 2s. So it's going to be 2, 2, and 2. And then this column will still be 1, 3, and 5. All right. So I start at the start value. And what I'm going to do is I'm going to go up 2 spaces. So I'm right here. I'm going to go up 2 spaces and then write 1 as I have in the table. And then I have my point here. We're going to do it again. We're going to go up 2 spaces and then write 3. So we're going to go up 1, 2, 1, 2, 3. So we're going to be over here. And we're going to do it again. So we're going to go up 2. And this time we're going to go right 5. So 1, 2, 3, 4, 5. And that's really it. And then all you're going to do is after you have these points, you can just sketch the curve. And that's your radical graph. That's really it. Let's take a look at another one. So the next one that we're going to do is we're going to look at the graph y equals the square root of x minus 2 plus 3. And again, the coefficient, if I don't see any number in front of the radical, is going to be a 1. So again, I like to write out my pieces. Here is my a right here. So we're going to say a is 1. H will be right here, and here is K. So remember, when we take H outside of the radical, it's actually going to change. It's negative here, it's going to change to a positive. And K doesn't change any sign, so there is the H and the K. So again, steps, I like to find my direction. I want to know if the graph is going left, right, up, or down. And again, for that, we're going to look at A, whether A is positive or negative. That tells me if the graph is up or down. And the coefficient of x is going to tell me if the graph is going to point left or right. And since this is positive and this is positive, again, the graph is going to go up and then right. Okay? And the next step we're going to do is the start value. So that will be my h and my k, once again. And then we said h and k was 2 and 3. So this will be 2 and 3 will be the start value. I'm going to put that on the graph. Just going to move this up just a little bit. We have 2 comma 3. And then all we need to figure out is the steps. So we have our Again, I'm just doing this for the visual here. We really don't need to make the table at this point. So this up column, we know the graph is going to go up, so it's going to be 1, 1, and 1, and the general steps are going to be 1, 3, and 5. And then since A is actually 1, I don't have to multiply anything in this column. So we can just keep the basic table. So from the start point, we're going to go, as it shows you right here, we're going to go up 1 over 1. So we're going to go up 1 over 1 to here. Then from this point here, we're going to go, like we see right here, we're going to go up 1 over 3. So up 1 and then 1, 2, 3. So we're going to wind up being at 6. And then one more time, we're going to go up 1 over 5. So we're going to go up to 6 and then over to 5. So we'd be here at 11. And then sketch the curve. And that's it for that one. All right, let's move on to one more. Let's do one where it's actually going to be reflected. Let's graph y equals negative square root of x plus 3 plus 1. This time my a term is negative 1. It's right here. My h, again, we're going to take this out. It's positive, so it's going to come out as a negative. And then here is my k, so k will be 1. All right, so this time my direction, since a is negative, it's actually going to walk downward. But we look inside here, the coefficient of x is positive, it's still going to go right. All right, my start value is still going to be, again, hk. So hk is, for this graph, is going to be negative 3, comma 1. So we're going to put that on the graph. So we're at negative 3 and 1. And the steps. So this time we're going to go walk down and then right. So, the right pattern will always be 1, 3, and 5. But this time, since a is a negative 1, the normal pattern would be 1, 1, 1. But again, we multiply the negative 1 times that column. So now we're actually going to be, if this is the down column and this is the right column, it's actually going to be minus 1, minus 1, minus 1, and then 1, 3, 5. That's just telling me that we're going to walk down. All right? So let's just be careful with that one. So from here, we're going to walk down 1, we're right here, and we're going to go right 1. So we're actually going to be over here. And then we're going to walk down 1 again, and we're going to go right 3. 1, 2, 3. So we'd be right there, based on this value in the table. And then one more time, we're going to walk down 1 and then 5 to the right. 1, 2, 3, 4, 5. So we'd be at 6, negative 2. And then we'd sketch the curve this way. So we're going to wind up coming down like this. Right? And then one more. So we've always gone to the right. Now this time we're going to skip a little bit, and we're actually going to move over to the left. Now, for this example, what we're going to do is we're going to graph y equals the square root of negative x. We'll do plus 6. When you see this coefficient here is negative, you should really factor that out. You really don't want to mess around with a negative coefficient under the radical here. So that's just a little tip from me. So I'm going to factor that out. We're going to have negative 1. And then when I factor the negative 1 out, basically these two will change signs. Okay? So this is going to wind up being a positive, and this will be a negative. This is a little easier to determine what your h is if you factor this negative out. It's always easy to, work with a positive x value. And then since we don't have a k term in the original function, your k would be 0. All right, so it would be 0 down here. So if I list my pieces, a equals 1, because that's my coefficient here. H now is right here. So when it comes out of the radical, it's actually going to come out as a positive because it's negative. And then k is 0. All right? So first step would be to do the direction. And then again, my coefficient of A is positive, so I know the graph is going to go up. But if I look at the coefficient of X here, it's actually negative. And we said from the beginning of this video, if my coefficient of X is negative, the graph is actually going to go to the left. The next thing we're going to do is our start value. And we said the start value is going to be my H and my K, so it's going to be 6, 0. I'm going to put that on the graph. But this time I have to remember, I'm not going to walk up to the right. I'm actually going to move this graph to the left. So then we're just going to figure out our steps. And we're going to wind up going up and left. And my A value is 1, so I'm not really going to change anything in this column. I don't have to multiply anything in this up column. So it's going to wind up being up 1, up 1, up 1 again. And then the pattern is going to be left 1, left 3, left 5. All right. So from this point right here at 6, 0, we're going to go up 1, left 1. So we're going to be at 5, 1. Then we're going to go, as our normal pattern here, and then we're going to go up 1, left 3. So up 1, 1, 2, 3 will be at 2, 2. And then one more time, we're going to go up 1, left 5. So up 1, 1, 2, 3, 4, 5. And we'll be at negative 3, 3. And then we can just sketch this curve. And it would look like that. So that's the basics of it. So a little tip again, whenever you have a negative coefficient under the radical in front of X there, a little tip that I like to do is I just like to factor out that negative, and then it makes it easier for me to determine what my start value would be. All right. Hopefully you enjoyed the video on graphing radical functions, and I will catch you in the next video. Take care.